Recording in progress.
All right, in this video, we're going to talk about, we'll begin chapter 2, dealing with approaches to problem solving. And in section 2A, we're going to look at understand, solve, and explain. And here we're going to be using this three-step process, understand, solve, and explain, or by the acronym USE, to help us solve problems. The understand, solve, explain process is designed as a framework for solving problems, and it is generally not necessarily necessary to write out the 3 steps explicitly. So here is that 3-step process. Use, understand, solve, and explain. Short for use. In step number 1, you're to understand the problem. That is to think about what the problem asks you to do. And in some cases, you may have to draw a picture or a diagram to help make sense of the problem. And then ask yourself what the solution should look like. And then try to make a path, either mentally or in writing, that will lead you from your understanding of the problem to a solution. And then continually revisit your understanding of the problem. Okay. And then step number 2 is to go ahead and solve the problem. And that is obtain any needed information or data. You want to, for multi-step problems, you want to be sure to keep an organized, neatly written record of your work. And then double check each step as you work to avoid carrying errors through to the end of your solution. And then finally, constantly reevaluate your plan as you work. And then the final step, step number 3, is to explain your result. That is to be sure that your result makes sense. You want to make sure that your answer does coincide with what they're asking for you to do. So you want to make sure that result does make sense. You don't want to get an answer that's way different from what they're asking for. Also, recheck your calculations once more. Even better, find an independent way to check your results. Identify and understand any potential sources of uncertainty in your results. If you make assumptions, were those assumptions reasonable? And then write your solution clearly and concisely using complete sentences to make sure that the context and meaning are clear. Okay, so this is what that understand, solve, and explain process is. All right, so here's a couple of examples that we're going to look at here. In this example, using keywords is pretty much also helpful. You're buying 30 acres of farmland at $12,000 per acre. What is the total cost? So here we can apply that understand, solve, explain process. To understand, it's going to be this. The question asks about total cost. And one of the given units is dollars. So we expect the answer to be in dollars. Because in the problem, they're asking for what is the total cost. So the cost has to be in dollars. And then we're going to solve this problem. We carry out the calculation. Note that the price is given in dollars per acre. So we write the division by acres in the form of a fraction, as you can see here. They put $12,000 on top and then acre in the bottom. Okay, it's in the form of a fraction. That will allow the acres to divide out. As here, if you were to simplify this, this unit, which is acres, divides out, leaving the final answer in dollars. So that means we got 30 times $12,000, which is $360,000. Okay. Now the next page is the explain part. So here we found purchasing 30 acres of farmland at a price of $12,000 per acre will cost a total of $360,000. Okay. So that's how we use that use, solve, and explain process to solve problems. Here we're going to look at principles of unit analysis. Okay. In this section and in the next section on another video, we're going to be talking about unit analysis in detail. Here's some definitions that we'll start off with. The units of a quantity describe what that quantity measures or counts. Okay. And the units can be anything. It could be things like inches or feet, or things like number of books or acres, as we saw in that last example. Unit analysis is the process of working with units to help solve problems. Okay, so here we're going to be using unit analysis to solve some of these problems, like in this example. Here I want to show operations and units clearly to answer the question. What is the total distance traveled when you run 7 laps around a 400-meter track? So in this case here, we can express the same idea as 7 laps of a 400-meter track. Therefore, this problem represents multiplying 7 laps by the 400-meter laps you run per lap. And here's the setup. 7 laps, then we multiply that by 400 meters per 1 lap. Notice that 400 meters is in the numerator and the lap is in the denominator. That way, laps, which is this unit, divides out. So we multiply 7 times 400, which would be 2,800 meters. So to answer this question here, the total distance traveled would be 2,800 meters. Okay. Now let's look at some problems that are or examples that are similar to the ones that are in your homework for this section 2A. It says here, how much will a person pay for 3.8 pounds of bananas at a price of $1.75 per pound? All right, so now let's set this problem up if we can. We got 3.8 pounds that a person is paying for bananas. So we have 3.8 pounds. We're going to multiply that by $1.75 per pound. So here we can write this as the dollar amount in the numerator, $1.75. What's after the word per would be in your denominator. I'm going to say 1 pound. Okay. So as you can see here, the pounds divide out. So that means you're going to do 3.8 times $1.75. And when you do this on your calculator, you will get $6.65. So that means here the price that the person will pay will be $6.65 total for 3.8 pounds of bananas. All right, here's the next homework example. What is the total weight of 8 basketballs that weigh 22 pounds each? The total weight of 8 basketballs that weigh 22 pounds each. Okay, so here we can set this up. We have 8 basketballs. So we have to multiply that by 22 ounces each. So 22 ounces per basketball. As each basketball weighs 22 ounces. And we have 8 basketballs. So we want to find out what that total weight is going to be. Now, when we simplify this, you're going to see that the basketballs divide out. That unit divides out. You'll have 8 times 22, which ends up being 176. And this will be 176 ounces. Okay. And if I go back to problem number 1, you're going to see here the choice of answers, either pounds or dollars. In this case here, in example number 1, it was dollars. So you want to make sure that you check that off in the homework when you're answering that question. All right, here's one more of these. If a person is paid $430 for 24 hours of work, what is the person's hourly wage? $430 for 24 hours of work. Well, in this case here, we need to do some division here because this person was paid $430, and that amount represents 24 hours of work. So here, we need the hourly wage. It's going to be some dollar amount per hour. So if I do $430 divided by 24 hours, I guess I'll go and show you this on the calculator. So this 430 divided by 24. Now in this case here, they want this rounded to 2 decimal places. So 17.91666 repeating. This 6 will make the 1 a 2, so it'll be 17.92 or $17.92 per hour. So the person's hourly wage is $17.92 per hour. Okay. All right. Now here we're going to look at some keywords and operations with units. And we talked about a few of these already. Like the word per, the operation for that would be division. So in this case here, miles divided by hours will be read as miles per hour. Now, the word of or something with the word height with a hyphen in it, that implies multiplication. So kilowatts times hours can be read as kilowatt hours with a hyphen in between those two words. And then for square, that operation would be something like raising to a second power, okay? So 5 squared, that means 5 to the second power. And we can read feet times feet or feet squared. And that's also as square feet or feet squared. And then cube or cubic means to raise something to the third power. So feet times feet times feet would be something like this. And we can read that as cubic feet or feet cubed. Okay. All right, now here's a homework example, somewhat similar to that. And it says here, a warehouse is 59 yards long, 35 yards wide, and 7 yards high. What is the area of the warehouse floor if the warehouse is filled to half its height with tightly packed boxes? What is the volume of the boxes? Then part B, what a room has a rectangular floor that measures 26 feet by 17 feet and a flat 8-foot ceiling. What is the area of the floor and how much air does the room hold? Then part C, a grain silo has a circular base with an area of 203 square feet and is 21 feet tall. What is the total volume? Let's start with part A. Here we have a warehouse that's 59 yards long, 35 yards wide, 7 yards high, and we want the area of the warehouse floor. Well, anytime you're finding the area of something, of a rectangular object, it will be length times the width, which means here the length here is 59 yards long. That's your length. So this is 59 yards times the width, 35 yards wide. That's your width. So if we multiply 59 times 35, you'll get 2,065. And the area has to be in square units. So we're dealing with yards. That means we write that as yards squared or square yards. So the area there will be 2,065 square yards. And then the other part of part A is this: if the warehouse is built to half its height with tightly packed boxes. So let's find the height. Seven yards high, but it's half. Because in the problem here, the warehouse will be filled to half the height. So if we take half of 7, this will be 3.5. Okay, that you can type in the calculator as 7 divided by 2. You'll get 3.5. So the height that we're going to be dealing with is 3.5. And this will be in yards. So now from that, we can find its volume. The volume there is, of course, length times width times height. That's fun. That's how we find the volume of any rectangular prism or solid. The length is 59 yards. And I multiply that by the width of 35 yards times the height, which is this time 3.5 yards, because the warehouse is built to half of its height. So half of 7, since it's 7 yards high, would be 3.5 yards. If you multiply 59 times 35 times 3.5, you will end up with 7,227.5, and the volume is in cubic units, so it has to be cubic yards. So the volume of that of the boxes is 7,227.5 cubic yards. All right, now part B. A room having a rectangular floor that measures 26 feet by 17 feet and a flat 8-foot ceiling. And we want the area of the floor and how much air does the room hold. So here, the area is again length times width. So that area would be 26 feet times 17 feet. Multiply 26 times 17, you'll get 442. And the area has to be in square units, so it has to be square feet. And then how much air does a room hold? Well, in this case, it has to be the volume. That's going to be length times width times height. So here we take 26 feet times 17 feet times 8 feet. So 26 feet times 17 feet times 8 feet will end up being 3,536 cubic feet. Okay. And then part C. A green silo has a circular base with an area of 203 square feet. So we already know what the area there is. 203 square feet. And is 21 feet tall. That has to be the height. And they want the total volume. Well, there is a formula for a volume of a cylinder, but in this case here, we know what the area of the circular base. So that's the area of the base times the height. And that will help us find the volume. So the area of the base is 203 square feet times the height, which is 21 feet. So if you multiply 203 times 21, you'll get 4,263. And this volume is in cubic units. So it has to be cubic feet. All right, so that's the volume of that silo. Okay, let's look at another homework example. Here we're going to identify the units of the following quantities and state the units mathematically and in words. Your average speed on a long walk found by driving distance traveled in inches by time elapsed in seconds. And we want to know what the units are mathematically. In this case here, we're dealing with inches per second. So we have to select this inch choice right here that says inches, that has inches over second. So the inches per second for this situation. And in words, it would be this answer choice here, inches per second, written like this. Okay. All right, this next example, similar to that previous one. The flow rate of a hose found by dividing the volume of water that leaves the hose in gallons during a period of time measured in hours. So here we're dealing with gallons during a period of time in hours, so that has to be gallons per hour. And the notation for that would be this answer choice right here, GAL, and then hour, HR in the denominator. And then what are the units in words? Has to be gallons per hour. You just have to pick the one that says gallons per hour, because that's the unit, that's the units that we're using in this case. Okay. All right, on the next page. Let's say we had this. What is the total cost of 1.5 cubic centimeters of soil if it sells for $40 per cubic meter? The total cost of 1.5 cubic meters of soil if it sells for $40 per cubic meter. Okay. So here we have 1.5 cubic meters. And I'm going to write it like this, for cubic meters. And it sells for $40 per cubic meter. So we're going to multiply that by the $40. And over it would be 1 cubic meter, because it's $40 per 1 cubic meter. That way these cubic meters divide out. So if I do 1.5 times 40, I would end up with $60. So the final answer is going to be, has to be in dollars. So it'll be $60. Okay. All right, let's take a look at example 8. A hose fills a hot tub at a rate of 2.5 gallons per minute. How many hours will it take to fill a 267-gallon hot tub? Okay. Now we have a we know 2.5 gallons per minute. That's the rate. So I'm going to write this as 2.51 gallons per 1 minute. I'm abbreviating the minute here. Now, it says how many hours will it take? Well, we need to convert this to hours here. I do know that 1 hour is equal to 60 minutes. In this case, that's just common knowledge. 1 hour is 60 minutes. So to convert that to to hours, the hours, which is my unit, has to go in the numerator. I'm converting from minutes. I'm sorry. I need to put the minutes on top. The reason for that is I want those minutes to be divided out. So the 60 minutes is in the numerator. The 1 hour will be in the denominator because I want this in gallons per hour. That way, I can find out the number of hours it's going to take. So here these minutes divide out. And if I do 2.51 times 60, this will be equal to 150.6. And this is going to be in gallons per hour. Okay. So I have my rate in gallons per hour. Now I want to fill a 267 gallon hot tub. And I want to know how many hours it's going to take. This time I need to do division instead of multiplication. Okay, because I have 267 gallons. And I need to divide that by the 150.6 gallons per hour. Well, anytime you multiply, anytime you divide, you have to multiply by the reciprocal here. So I'm going to bring this 267 over times the reciprocal, just flip this over or do inverting. So I'm going to say 1 hour over the 150.6 gallons. And I do need to write this unit gallons in there as well, because that's what 267 gallons is. Then I'm going to divide out the gallons. So I have 267 times 1, and then that's divided by 150.6. Now, if you round this off to 2 decimal places, now we'll show you on the calculator. 267 times 1, divide that by 150.6. That'd be 1.77 if we round this off to 2 decimal places. Okay. So 1.77, and this is going to be in hours. So it's going to take 1.77 hours to fill up a 267-gallon hot tub. Okay. All right, take a look at homework example number 9. Sid needs 0.8 meters of canvas material to make a carry-all bag for his wheelchair. If canvas is $11.42 per meter, how much will Sid spend? And they want you to note that $11.42 per meter is the same as $11.42 for 1 meter. Okay. So here we got 0.8. That's in meters. We're going to multiply that by the $11.42 that goes in the numerator. And that's for 1 meter. That has to go in the denominator. Okay. So in this case here, meters divide out. That way your answer will be in dollars. So 0.8 times $11.42 will end up being, I think the 2 decimal places, this will be $9.14. Okay, because if we do 0.8 times 11.42, you'll get 9.136, but that's 6 will round a 3 up to a 2. I mean to a 4. So it'd be approximately $9.14. And that's for 0.8 meters of canvas material to make a carry-all bag. All right, example number 10. If your car gets 29 miles per gallon, how much does it cost to drive 350 miles when gasoline costs $3.50 per gallon? In this case here, let's start with that 350 miles. Your car gets 29 miles per gallon, so we need to do some division here. We're going to do divided by 29 miles per 1 gallon. Notice I'm abbreviating miles and I'm abbreviating gallons here. Okay, so when I divide, I have to take the reciprocal. I have to multiply by the reciprocal, so it'll be 350 miles times its reciprocal. Flip this over, it'll be 1 gallon in the numerator and 29 miles in the denominator. So in this case here, the miles divides out. So I have 350 times 1 divided by 29. But I'm also going to extend this here because now it's in gallons. I also have this $3.50 per gallon. So I can go ahead and multiply $3.50 per 1 gallon. That way, gallons divides out. All I'll be left with will be just $1 amount. So 350 times 3.50 divided by 29. Rounded to 2 decimal places, since we're dealing with money amounts, it's going to end up being $42.24. $42.24. Okay, so the cost to drive 350 miles when the gas is $3.50 per gallon. If the car gets 29 miles per gallon, that cost will be $42.24. Okay. All right, on the next page is unit conversions here. Another important use of unit analysis comes in converting numbers from one unit to another unit, such as from miles to kilometers or quarts to cups. And here we have conversion factors. And that's a statement of equality that is used to convert between units. And these are just some of the conversion factors here that are used here. Like 12 inches is equal to 1 foot. Or we can say that 12 inches over 1 foot is equivalent to 1, or 1 foot over 12 inches is also equivalent to 1. Another one, 24 hours equals 1 day, which is the same as saying 24 hours over 1 day will be equal to 1, or 1 day over 24 hours. If you take the reciprocal of that, that too is equal to 1. So here's some examples here, like this one. Number 11. Convert 24 feet to inches. Okay. The fact is, you have to know that that 1 foot is equal to 12 inches. So I'm going to take that 24 feet, multiply it by, and we want to convert from feet. So that means the unit of feet has to be in the denominator to inches. Inches has to be in the numerator. And 12 inches, that 12 has to go with the corresponding unit, is equal to 1 foot. The 1 has to go here. The feet divides out, so we got 12 times 24, or 24 times 12, whichever you want to call it, would be 288, and the answer will be in inches. Okay. All right, number 12, convert 11 minutes into seconds. Well, we have to know that for every 1 minute, that's equivalent to 60 seconds. 1 minute is 60 seconds. So if we want to convert minutes to seconds, these 11 minutes will be multiplied by what we're converting from goes in the denominator. We're converting from minutes, that goes in the denominator, to seconds, seconds goes in the numerator, and we put the corresponding values for those units. 60 seconds, the 60 has to go in the numerator. 1 minute goes in the denominator. So here your minutes divide out. So now we multiply 11 times 60. In this case, that's going to be equal to 660 seconds. So 11 minutes is 660 seconds. Okay. All right, next we'll look at converting 5.4 hours to seconds. 5.4 hours to seconds. Of course, 60 minutes is 1 hour. And of course, 60 seconds, as I mentioned in the last example, is 1 minute. All right, and we got 5.4 hours. Now, let's convert from hours to minutes, and then from minutes to seconds. Let's start with that. We're converting from hours, so the 1 hour has to go in the denominator, to minutes. 60 minutes goes in the numerator. That way, your hours will divide out. Now, our answer will be in minutes, but we need to go from minutes to seconds. Well, 60 seconds would make up 1 minute, so let's do this. We're converting 2 seconds, so the 60 seconds has to go in the numerator. We're converting from minutes, so the 1 minute goes in the denominator. So here your minutes divide out. Our final answer will be in seconds, so we have to do 5.4 times 60 times 60, which will end up being 19,440 seconds. 19,440 seconds. So 5.4 hours will convert to, or is equivalent to, 19,440 seconds. Okay, next page deals with conversion of units raised to powers. Here we're going to take special care when converting units that are raised to powers like this one. Let's say we know that 1 yard is equivalent to 3 feet. 1 yard is equivalent to 3 feet. Now, if we square both sides, because 1 yard squared will be 1 yard times 1 yard, and a yard is 3 feet, and another yard is 3 feet. So 3 feet times 3 feet will be 9 square feet. So 1 squared yard is equivalent to 9 square feet. And here you can see how that is illustrated here. You got 9 small 1 square feet squares. Okay. And you can see that it's going to be 9 square feet. Okay. Because you can see 1 yard is 3 feet. 1 yard, again, 3 feet. So 3 feet times another 3 feet, that's 9 square feet, which is equivalent to 1 square yard. All right, let's use this idea with example 14. An air conditioning system can circulate 330 cubic feet of air per minute. How many cubic yards of air can it circulate per minute? All right. I know for the fact that a yard is equivalent to 3 feet. We already discussed that. Now we're dealing with cubic feet. Now, what I'm going to do here is cube both sides of this equation to get this in cubic yards. Okay, so 1 cubed, or 1 times 1 times 1 will be 1, and this will be in cubic yards. 3 cube, think of 3 cube as 3 times 3 times 3. That will be 27. And this will be in cubic feet. So 1 cubic yard is equivalent to 27 cubic feet. Now we got 330 cubic feet. We want to find out how many cubic yards of air can circulate per minute. 330 cubic feet of air per minute. That's a rate, actually, I should say. So 330 cubic feet per 1 minute. We're going to convert from cubic feet to cubic yards. So the cubic feet has to go in the denominator. The cubic yards goes in the numerator. Cubic yards is 1 cubic yard that goes in the numerator, equivalent to 27 cubic feet. The 27 has to go in the denominator. So, and by the way, you're going to see that the cubic feet divide out. You'll be left with an answer in yards per minute. So 330 divided by 27. Let's see, to 1 decimal place is 12.2. So my answer there will be 12.2 cubic yards per minute. So that's how many cubic yards of air that the air conditioning system can circulate per minute. So we're looking for a rate there. All right, currency conversions is the next thing we'll look at here. Converting between currencies is a unit conversion problem in which the conversion factors are known as the exchange rates. And in this table that you see down here, it shows a typical table of currency exchange rates. Okay, so pretty much you'll see the first column are your currencies. The next column is the dollars per foreign currency. And then foreign currency per dollar is the last column. Okay, so on this next page is an example of just that currency conversion. So we'll look at that. It says that gasoline sells for 1.2 euros per liter in a city in Europe. What is the price in US dollars per gallon? And recall that 1 gallon is going to be equivalent to 3.785 liters. Here they've given you that to assist you in finding the answer. All right, 1.2 euros per liter. €1.2 per liter. Let's multiply that by converting from euros to dollars. Here's the European euro. From dollars per foreign per euro is 1.041. So we're going to multiply that by the dollar equivalency would go in the numerator, or the US dollar equivalency goes in the numerator. Per 1 euro, that goes in the denominator. Now you're going to see that your euros divide out, you'll be left with an answer in dollars per liter. We need this in US dollars per gallon, and we're told that 1 gallon is 3.75 liters. So let's use that. Since liters is in the denominator, we need to put the liters here in the numerator and the gallon in the denominator. 1 gallon, the 1 goes in the denominator. The liter, 3.785. That goes in the numerator. That way, you'll see that your liters divide out. So we're going to have 1.2 times $1, $1.041 times 3.785. Now, if we round our final answer to 2 decimal places, I'll go ahead and type this in so you'll see that I'm not making this up. 1.2 times 1.041 times 3.785 to 2 decimal places, that would be 4.73 or $4.73 per gallon. Okay, that's the price of gas in US dollars. Okay. Here's some further applications to unit analysis here. A commuter train travels 31 kilometers in 28 minutes. What is the speed in kilometers per hour? All right, so we got 31 kilometers. Has to be a division problem in 28 minutes. So that's going to be divided by 28 minutes. The problem is we want this in kilometers per hour. All right, we have minutes. I know that 60 minutes makes up an hour. I'll write that up here. 60 minutes is equivalent to 1 hour. So that means here, the minutes will have to go in the numerator because I want to get rid of the minutes. Hours will have to go in the denominator. 60 minutes, which is the 60, goes here. The 1 hour goes in the denominator. So here your minutes are going to divide out, so you'll be left with an answer in kilometers per hour. So if I do 31, okay, 31 times 60 divided by 28. To 1 decimal place, this will be 66.4 kilometers per hour. So 66.4 kilometers per hour. And they do give you space to fill in your answer. So it'll be like 66.4, and then you have to choose which one, kilometers per hour. And finally, number 17. You plan to take a 1,170-mile trip in your car, which averages 20 miles per gallon. How many gallons of gasoline should you expect to use? And would a car that has only half the gas mileage require twice as much gasoline for the same trip? Okay. So we're planning to take a 1,170-mile trip. And it averages 20 miles per gallon. So we got to do division here. So this will be 1,170 miles divided by the 20 miles per gallon. Because we want to find out how many gallons of gas we're going to need for this trip. Well, let's do this. 1,170 divided by 1, this in miles, times the reciprocal of 20 miles per 1 gallon. So the 1 gallon has to go in the numerator. When you invert, 20 miles goes in the denominator. That way, the unit of miles divides out. So the 1,170 divided by 20 you're going to end up with 58.5 gallons. So you should expect to use about 58.5 gallons of gasoline. Now, would a car that has only half the gas mileage require twice as much gasoline for the trip? So we were dealing with 20 miles per gallon, so half of 20 would be 10. So half of 20 miles per gallon, that's going to be 10 miles per gallon. Okay, so we're going to take that 1,170. We're going to take that 1,170, divide that by 10 miles per 1 gallon. And of course, when we divide fractions, we always multiply by the reciprocal. So it would be 1,170 miles times the reciprocal, 1 gallon in the numerator, 10 miles in the denominator. Again, your miles divide out. So if you do 1,170 divided by 10, you're going to get 117 gallons. So 10 miles per gallon, you would need 117 gallons of gasoline. And the answer for that, and you're going to get a choice of either yes or no, it'll have to be yes. Because the car would use, in this case, 117 gallons, which is twice as many gallons of gasoline. Okay. Okay, so that does conclude this video on section 2A, dealing with understand, solve, and explain. All right, feel free to contact me if you have any questions on any of the homework that's for this section, or if you have any questions about any of the problems that were discussed in this video.